Hi everyone, good afternoon. We will discuss theorems on complex numbers, and we will start with Theorem 1. Once again, complex numbers are numbers composed of real and imaginary numbers. So, for instance, you have 2 plus 3i. This is a complex number where 2 is what we call the real part and 3i composes the imaginary part. So this is the real part, this is the imaginary part. Okay, so Theorem 1 of complex numbers states that if a complex number is equal to 0, then its two terms are equal to 0. Its real part and its imaginary parts are equal to 0. So Theorem 1 states that if x plus jy is equal to 0, then it follows that x is equal to 0 and y is equal to 0. Because if both are not equal to 0, then this would not be equal to 0 because a number added to 0 is that number. And if that number is not equal to 0, then it follows that we would not be getting a 0 here as the sum. Okay, so we will use this theorem to solve some problems. Let's start with the first problem we have here. Cosine squared theta minus sine squared theta plus j cosine squared alpha equals 0. Okay, so we will use the theorem 1 of complex numbers to solve r theta and alpha. Okay, so the first is theorem 1 states that if the complex number is equal to 0, then we need to equate its real part to 0 and its y to 0, the imaginary part to 0. So cosine squared theta minus sine squared theta is equal to 0, and at the same time j cosine squared alpha is equal to 0. Actually, we can simply remove j because when we divide both sides by j, cosine squared alpha, j cancels here, and 0 divided by j is 0 because any number, 0 divided by any number is still 0. So here we need to solve our theta, our angle theta. But if you are familiar with the identity cosine squared a minus sine squared a equals cosine 2a, the double angle identity of cosine 2a, we will use that to replace replace this expression. So this becomes cosine 2 theta equals 0. What is cosine 2 theta equals 0? What is the value of theta? So we take the arc cosine of 0 in order to obtain the value of theta. You know that arc cosine of 0 is equal to 90 degrees because if you recall, cosine at 0, at angle equals 0, cosine starts with a value equal to 1. Unlike the sine, which starts here, at 0, while cosine starts here and then starts going down to 90 degrees. So at an angle of pi or 90 degrees, the value of cosine is 0. On the other hand, at the angle of 0, the value of sine is 0 and it goes up. It has a value of 1 at 90 degrees or pi. So, since 2 theta is equal to 90 degrees, 2 theta divided by 2, we divide 2 both sides to obtain the value of theta. So theta is equal to 90 divided by 2, 90 degrees divided by 2, which is 45 degrees. Here, what we have is cosine squared alpha equals 0. We take the square root of both sides. Cosine squared alpha equals 0. Square root, cancel. Square root of 0 is 0. So this is cosine of alpha. Alpha now is equal to arc cosine of 0. Our cosine of 0 once again is 90 degrees. So alpha is equal to 90 degrees. So for this expression, x plus jy equals 0, for this expression, cosine squared theta minus sine squared theta plus j cosine squared alpha equals 0, we apply theorem 1 of complex numbers in order to obtain theta and alpha. And the values for theta and alpha are 45 degrees and 90 degrees respectively. Okay, we go now to our second problem. Our second problem, which we will use our theorem 1 in order to obtain the unknown. The unknowns is 1 minus tangent squared theta minus j square root of 1 minus sine squared alpha equals 0. Okay, so again, theorem 1 of complex numbers states that if x plus jy is equal to 0, then it follows that x is equal to 0 and y is equal to 0. Okay, so we will use that to solve theta and alpha in our second equation. So we equate the real part and the imaginary parts to 0. 1 minus tangent squared theta is equal to 0. Transposing tangent squared theta to the other side, we have 1 equals positive tangent squared theta. Taking the square root of both sides, we have square root of 1 is equal to 1, and square root of tangent squared theta is equal to tangent theta. So I will just switch the two. Tangent theta equals 1. Theta therefore is equal to arc tangent of 1, and you may use your calculators to obtain arctan 1, and that is simply equal to 45 degrees. So this is the value for our theta. And for the imaginary part, we have square root of 1 minus sine squared alpha equals 0. Take square both sides. Squaring both sides, we have 1 minus sine squared alpha equals 0. Okay, 0 squared is still 0. Then transpose sine squared alpha to the other side. We have 1 equals sine squared alpha. Take the square root of both sides. Okay. We have square root of 1 is still 1, and we have sine of alpha. Sine of alpha, in order to get alpha, we have arc sine of 1 is equal to alpha. And alpha is equal to arc sine of 1 is 90 degrees. Arc sine of 1 is 90 degrees because, as I've said earlier, sine begins at, for angle 0, sine, the value of sine is 0, and then for pi or 90 degrees, the value of sine wave is 1, and then it begins to go down again. So the value of sine pi or 90 degrees is 1. That is why arc sine 1 is 90 degrees. Well, we have another alternate solution to this one, and that is, if you recall the Pythagorean identity is sine squared a plus cosine squared a equals 1. And transposing sine squared a to the other side, we have cosine squared a equals 1 minus sine squared a. And taking the square root of both sides, we have cosine a equals square root of 1 minus sine squared a, which means that this expression is simply equal to cosine of a. So we can substitute this with cosine square root of 1 minus sine squared alpha is simply equal to cosine of alpha, and that is equal to 0. And so alpha is equal to arc cosine of 0, and arc cosine of 0 is equal to 90 degrees, because as we have said, cosine wave starts at angle equal to 0. Its value is cosine 0 is 1, and then for 90 degrees or pi, the value of cosine is 0. That is why arc cosine of 0 is 90 degrees. Arc cosine of 0 is 90 degrees. Okay, so that's our second problem using Theorem 1 of complex numbers. Okay, our next problem is cosine 2 theta to the power of 4 minus sine 2 theta to the power of 4 plus j cosecant squared alpha minus 1 equals 0. So we are to obtain theta and alpha. This is our real part and this is our imaginary part, the one with a j. So how do we solve theta and alpha? We use the Theorem 1 of complex numbers, where we equate the real part to 0 and the imaginary part to 0, because Theorem 1 of complex numbers states that if a complex number is equal to 0, then both its real and imaginary parts are equal to 0. So cosine 2 theta to the power of 4 minus sine 2 theta to the power of 4 is equal to 0. You remember that this has an identity. This can form a difference of two squares, although this is to the fourth power, but we know that the fourth power is the square of a square. So difference of two squares, if you recall, a squared minus b squared is equal to a plus b times a minus b. So then, since this resembles difference of two squares, we can substitute this with cosine squared 2 theta minus sine squared 2 theta plus times cosine squared 2 theta plus, this time plus and minus and plus, so or plus and minus to in order to correspond to our expression above. So cosine squared 2 theta, cosine 2 theta squared, minus sine 2 theta squared equal to 0. And you recall that you probably recognize this as resembling a Pythagorean identity. And you recall that cosine squared a plus sine squared A is equal to 1. So this whole expression is simply equal to 1. And we have this cosine squared 2 theta minus sine squared 2 theta equals 0. Remember that this has an identity, and that is the double angle of cosine identity, where cosine squared A minus sine squared A is equal to cosine 2A. Okay, so but cosine squared A minus sine squared A is equal to cosine 2A. So therefore, this is equal to cosine of 2 theta, 2A, where A is 2 theta. So this is equal to, this whole expression is equal to 0. Cosine 4 theta therefore is equal to 0. And 4 theta is equal to arc cosine of 0. Again, arc cosine of 0 is equal to 90 degrees. So 4 theta is equal to 90 degrees. Divided by 4, both sides. Theta now is equal to 22.5 degrees. So this is the value of our theta. And we now solve the other side, which is cosecant squared alpha minus 1, and we equate it to 0. So that is cosecant squared alpha minus 1 equals 0. Transpose 1 to the other side, we have cosecant squared alpha equals 1. Take the square root of both sides, we have cosecant alpha equals 1. Square root of 1 is 1, right? So cosecant alpha equals 1. But cosecant alpha, what is cosecant alpha? Cosecant alpha is simply equal to 1 over sine of alpha. It is the inverse of sine. Okay, so the reciprocal of sine, I mean. So 1 of sine alpha is equal to cosecant alpha, which is equal to 1. Transpose this to the other side, we have 1 is equal to sine alpha. Therefore, in order to get alpha, alpha is equal to arc sine of 1. Arc sine of 1. And alpha, therefore, is, what is the arc sine of 1? Arc sine of 1 is simply equal to 90 degrees. Again, because sine wave starts at 0 and then it reaches its peak at 90 degrees, in which it has a value of 1. So sine 90 is equal to 1. Therefore, arc sine of 1 is equal to 90 degrees. So theta for this expression, which is our third problem, cosine 2 theta minus sine 2 theta, both are to the power of 4, plus j cosecant squared alpha minus 1 equals to 0. The values for theta and alpha, which will satisfy the equation, are 22.5 and 90 degrees respectively. So we have learned how to what is Theorem 1 of complex numbers and how to apply it in order to solve the unknowns of equations involving complex numbers. Please proceed to the next video for the Theorem 2 and Theorems 2 and 3 of complex numbers. Thank you and God bless.